Welcome to episode 4 of Tacit Talk. My name is Connor, your host, and today with us we have our fourth guest of the Tacit Talk podcast, Adám Brudzewsky, who probably 99% of either the watchers on YouTube or the listeners on the podcast know of already, as he is one of the panelists on my other podcast, Arraycast, and I believe other than Bob Terrio, one of the panelists, you are probably the second most frequent panelist, because I think Bob has been there for every single one, and you have been there for N minus, I'm not sure, maybe 5 or 10, because I think sometimes Richard Park, a fellow coworker of yours, substitutes in when you are busy. And Adam is the head of language design and development at Dyalog Ltd, the company that makes the Dyalog APL interpreter, which, if you haven't heard on any of the other, YouTube videos or podcasts, is freely available to use at dialog.com. I think there's a link in the description of this YouTube video and in the show notes of the podcast. Welcome to Tacit Talk, Adam.
Thank you. I'm so happy to be here. Really excited.
Yeah, I am super excited. We're going to talk all things tacit programming in Dyalog APL and maybe APL and some of the other array languages. So I think we're going to do things a little bit differently in this episode, because one thing that sets APL, specifically Dyalog APL, apart from the other languages that we have covered on this podcast, aka WiWA, BQN, and CAP, and I guess also because we spent half an episode talking about Marshall Lochbaum's first language, is that there is a plethora, a cornucopia of resources online in the format of not just YouTube videos from conference talks and YouTube videos from seminars, but also there are several books that have been written on Dyalog APL. There's the OG Mastering Dyalog APL, and then I think there's a newer one called Learning APL by Stefan Kruger. I might actually have the name wrong there. There might even be, I'm not sure if you know any other books off the top of your head that are specifically about Dyalog APL, but I know those two definitely exist. And
Ray Polivka just published a book called Programming in the APL. It's still a bit rough, but it's getting there. So it's
yes.
brand
I
new,
actually
fresh
have a
off the
copy
press.
sitting on my shelf from Minnowbrook back in October of 2023, which, wow, is already almost a year ago at this point. It doesn't feel like that long ago, but time flies. And so there are a ton of resources. I'm not sure how many. I know there's 2 different YouTube channels. Hopefully Adam knows them off of his head. I think one of them is Dyalog Conferences, and the other one is Dyalog Ltd. But we will make sure to link. Does that sound about right?
I think it's Dialog User Meetings. Yeah.
Dyalog User Meetings and Dyalog Ltd. So we will make sure we'll link it both in the description of the YouTube video and the podcast show notes. So and I think one of them, it's probably the user meeting, is the one that all the annual conference talks get posted to, correct?
Right.
Which I think, I'm not sure, I mean, this is coming out live today, so tickets are still available. That's happening, I believe, September 15th or 16th? T-minus, I think, a month?
Yeah, something like that, yeah.
So if you are either close or not close, and you don't mind hopping on a plane, I believe it's being held outside Glasgow in the UK. And yeah, there's going to be a ton of conference talks given there. But all of the conference talks from years past, dating back to, I think, 2010. So there's like a decade plus of conference talks you can go and check out, which sets it apart because the other languages that we've covered don't have conferences, don't have companies attached to them. So there's not the plethora of resources out there to go and access if you're trying to learn.
I think you can actually, you can miss out on something by just watching the videos, because there's something not spoken about much. This user meeting conference, it runs from a Sunday to Thursday, and Sunday and Thursday are entirely just workshops. So that means you're there with experts on subjects for half-day hands-on activities. That's very different from just watching a presentation that you can see on YouTube afterwards as well.
Yeah. In the chat, Meme God, spelled GAWD, said that, or mentions that you ran the Tacit Workshop at the 2023 edition of the conference. Maybe you mentioned that, but I don't actually, it's off the top of my memory. That doesn't ring any bells. Do you want to mention, I assume none of that stuff was recorded, so you have to attend the workshop in order to get access to that sort of, those teachings. What did you cover?
Yes, that's good. Actually, all the materials are available online. Not a a video of it, but like all the slides that we presented, those are available. So we'll leave a link to that as well.
Awesome.
But I can look at the summary here for what we went through, and we went through and everything there is to know about tacit programming in Dyalog APL. So both the combinator operators and the trains, reading them, writing them. So when I run these workshops, it's always lots and lots of exercises, and then the format is that you give one or more tasks to the audience, and then myself and some helpers we go around while people are solving the problems and they look over the shoulders how they're doing, talk it through that with them, guide them so that they get the maximum out of it. And then we went through some of the upsides, downsides, some of the issues that are with tacit programming in Dialog, how to get around some of the issues, things to just stay away from, something about performance as well. And we are largely actually rerunning that workshop this year as well, because it was very popular. I think we're rerunning it twice. So this year we're duplicating multiple workshops, and we have like I think 3 parallel tracks of workshops,
Oh wow.
and so we've got loads of workshops you can choose. There's something for everyone.
So I imagine that most of the individuals that are sitting in that workshop are familiar with Dialog APL, or are there some complete beginners? Like, what do you know what the breakdown is? Is it like 90-10, 50-50, 100-0?
Um, I don't think there are any that are complete beginners.
Okay.
It is, I mean, to be honest, it's quite expensive to go to the user meeting.
Mm-hmm.
There are some private individuals, some retirees that go there used to be professional APLers. Most of the people I think are sent, that we call them delegates. They're sent by companies that use APL, and they will have at least some knowledge of APL. And I think all workshops we run also have that as a requirement. You have to at least basic or good knowledge, depending on what it is that's being taught. But we had some people that were relative beginners to APL. So there are some of our customers, they train their own APLers, and then they bring them after a little while to these user meetings to uh, get them up to speed on some advanced concepts and so on.
The reason I ask is because I'm curious to know what the experience is like for the individuals in the workshop. Like, is it on average folks that know Dialog APL but usually stick to trad funds or D funds, and then you're showing them techniques that they've seen but they don't usually use on a day-to-day basis, and then you kind of open their eyes and they say, oh, I could see how this would be super useful? Or is it people that are kind of already halfway into the world of tacit programming, and they're just like, oh yeah, I've always wondered how a 7 train works or a 6 train works? Like, what's the typical experience, and are people's minds being blown, or is it more like they're, oh, I finally understand this thing that I've been kind of half understood but not fully understood?
I think it's both, but I think that people usually go to things that they either want to or need to know more about. Not they, but it depends a little bit. I have in the past run code golf workshops, and I mean, that's not something you want to do as a professional, but it's something that can help you be more familiar with the intricacies of the language. Just drilling that, getting used to problem solving, looking at things from various angles. Um, but we've definitely had people who come to a workshop that didn't know anything about that subject,
Right.
and want to learn from the beginning there. So something I've done in my workshops lately is when I give tasks, then I add 1 or 2 bonus tasks that are on a higher level. So those people that already know the basics, they have something to fight with, while those that are new to the subject, they just tackle the easier problems.
Interesting.
And we've definitely had. I remember very clearly there was some and a lady from a relatively large APL user, that was she was very new. She warned me that she was very new to APL, and she was in this. I think it was, yeah, she was in the Tacit workshop, and she just exclaimed in the middle like I remember exactly what it was. She says like wow, like I got it, and like she was very excited about this whole thing and getting into it, and it was a new thing for her. So that definitely exists.
Awesome. I mean, I've actually never. There's two of the past user meetings I've intended on going to. One of them was the one, I believe, in Portugal, and I actually meant to attend the upcoming one as well. But I had a friend schedule a wedding, which is something typically is a once in a lifetime thing that you can't miss. But at some point, I will hopefully attend one of these, and maybe I'll get to sit in on a Tacit workshop. Yeah, so we should hop into things. I'll throw you one of two questions. Like, we can either bring up the tweet that I just tweeted out, or we can start off with, the pitch for Tacit, which has come up one or two times on a Raycast, because I know that you are definitely in the camp of you are a fan and a promoter of Tacit programming, whereas others are, explicit only. So I'll throw it to you. Do you want to bring up the tweet first, or do you want to talk about, why should people be interested in Tacit programming?
I guess we can do some introduction to why Tacit programming, but I also want to say a little bit about why people shouldn't do Tacit programming, because I promote it, I use it. I'm sometimes infamous for writing incomprehensible Tacit stuff, and I wouldn't shy away from using Tacit programming in production code, for sure not. I do that sometimes even in ways that my colleagues frown upon. Um, but as somebody wise said, write your code as if it's going to be read by a violent psychopath that knows where you live and is going to read it. Right. So you do want to cater to the user as well, and there can be issues with readability of Tacit, but on the other hand, Tacit can also help readability because you have maybe all the components right there concisely. You can see everything you're working with already. So there is the benefit of being more concise, of subordination of details that you don't need, names of the arguments. I think there's there's a difference in how the code feels. Manipulating Tacit code, it feels more like, to me at least, more like a mathematical manipulation of symbols than explicit code. I think it can help sometimes reason about it and come to conclusions of things that are equivalent but better stated. I think it'd be easier to spot what the differences are between variations in an algorithm. But there are definitely ways to write Tacit code as well that makes it hard for people to read. It can be somewhat ambiguous. APL and similar languages have the you could call it problem, feature, whatever, that primitives often can be both monadic and dyadic. They can take two arguments, one on each side, or just one on the right. And that means that if you don't explicitly state your arguments, then you don't have that hint as to which of the two meanings you're going to use. So if I just see a function, f gets some symbols, then in order to try to understand what this code is doing, I have to start reading it double-minded. Is it going to be used monadically or dyadically, or occasionally actually both? There are tricks to spot what the writer meant, and the author of such code can take those steps to explicitly kind of show how this code is meant to be used, even without writing a comment on it. But I can see how it could make people a bit more lost as to what the code is doing, which is not a problem in languages like Jelly that you have taken up, or Wewa, because there's a fixed arity on everything.
Yeah, that actually came up on, was it the last recording, or it might have been two recordings ago, on the Arraycast, of where I had this idea that I threw out there of like three different assignment operators for, I guess, I mean, you wouldn't really need them in a defun because based on whether the omega and the alpha show up, whether it's dyadic or monadic. But in the Tacit ones, if you had three different assignment expressions, you could have one for monadic, one for dyadic, and one for ambivalent. Is it a good idea? The jury's still out. But it would potentially resolve this ambiguity because you could, like, just the other day I was writing integer division. And that's just, minimum, or not minimum. It is the minimum glyph, but it's the monadic definition of the minimum glyph floor composed with the divide. And I honestly think that's like almost immediately readable that you want basically integer division there, because the alternative is reciprocal and then
Yeah,
like
the
floor,
floor of the
and
reciprocal.
that's just not really meaningful. Like because you're basically just zeroing out anything that is an integer value, or I guess if you have like a floating point number, it is reciprocaling it and then getting rid of whatever decimal points you have afterwards. But like that's kind of nonsensical. So like I think to me when I see that, it's like that's almost an idiom. It's not like one of the most popular idioms, but when I read that just by itself, it's like okay, clearly you want to integer divide. But
But
if you had a little assignment operator that had something that indicated this is defining a monadic function, it would then just be like it would cement your assumption that this is what it's meant for.
I think you can also hint for the user, the reader, sorry, um, what you mean by choosing carefully which composition operator you're using. In Dialog, there are three, well, all the composition operators do the same thing in the monadic case, but you can use that to hint at what you mean. So I like to think of the simple jot, and maybe we should bring up the the table, the jot of what we call now beside, and as pre-processing the right argument to a main function. So f jot g is basically f, but you're just pre-processing the right argument to f with g. And I like to think of the jot diaresis, the Atop, as post-processing. So you basically f Atop g is g, but you're just post-processing the result with f.
Right.
And then you have got the over where you are, or circle diaresis where you are pre-processing both arguments with g. So it's f, but pre-process both arguments. And you can use this to indicate what it is you have in mind, even when using the monadic case where they're all equivalent. So if you say if you say floor atop divide, then you're indicating that the main operation here is a division, but you're post-processing the division with a floor. That's an integer division. If you used a simple jot, then the main operation would be the floor or a minimum, and you're pre-processing the right argument with reciprocal. And that would be a possibility. You could use that dyadically. You take the minimum of A and the reciprocal of B. That's a valid thing to do. So choosing carefully which operator you use can help the reader as well.
So yeah, let's definitely bring up the tweet that I just tweeted out of the Combinator table, because this makes me think of something that I only recently, I don't want to say observed, but kind of thought about, which was the fact that in Dyalog APL there are multiple glyphs that use the monadic definition as the same composition operator as the B combinator. Whereas in, I think BQN, there is one glyph or two glyphs that share the same meaning, but then in CAP, there are no glyphs that share the same meaning. And actually, it affects the number of glyphs that you end up with, because I think CAP has like one fewer than definitely than BQN. I'll have to look at the table to see for sure. But yeah, we'll wait for a second while Adam shares his screen.
Oh, you want me to share it? Okay.
Yes,
I can do that.
because if I share it on my end, we will have a calamity of technical issues due to the fact that I'm just screen sharing for the YouTube people.
No problem. I will share my screen. There we go. That's the one. Okay. So what we're talking about here, we have the jot diaresis and the jot and the circle diaresis in their dyadic forms, and we can see that they're all bunched together in the monadic form over here. They all mean the same thing.
So yeah, what you were just making an argument for is that when you're reaching for unary function composition, aka the B combinator, you can communicate more semantic meaning by your choice of the glyph that you use. in that you were saying the jot diaresis, the circle with two dots over it. That one is for, if I recall, the pre-processing,
Post-processing.
post-processing, and then the single jot with nothing, that one's for the pre-processing.
That's pre-processing the right argument only, right? If there are two arguments, that's the thing. I'm kind of treating them as both the monadic and the dyadic form together. Whereas if you go by the combinatorial logic symbols for them, there is no connection between the monadic and dyadic forms. But I very much see them as connected. And actually, maybe I'll share something else as well, and that is in the Dyalog documentation for combinators, because I think that actually that shows the idea very nicely. So let's do that here. And in this table here, or diagram here, whoa.
And yes, in case you're listening to this as audio version, I mean, it was implicit when I stated that there was a YouTube stream of this, but just a reminder that there is always a YouTube video to go and watch this. We will do our best, though, to explain this stuff, because I do know some people prefer still listening to podcasts via their podcast apps. But yes, so we've got this Dyalog help page for operator syntax. And
we can link to that as well.
Yeah, we'll link this in both the show notes and the YouTube description after the fact.
And as opposed to the normal diagrams that are seen many places for these compositions that are just simple lines between arguments and functions, this is very much more like a flow of data. Where does the data go to the functions? And we can see that the one diagram is used for both the monadic and the dyadic form. The rule is simply that the left argument leg, whatever part of the tree that's associated with the left argument, just disappears in the monadic form. And therefore, it has to be that effectively they mean the same thing.
Right. Yeah,
definitely. So I think of them very much as the same thing. It's just two different uses.
Yeah, so this, I mean, there's three different diagrams here, atop, beside, and over. The dyadic of these, atop is the B1 combinator, which is applying a binary function and then taking the result of that and applying a unary function. Over is the next easiest, in my opinion. It's the psi combinator. It's applying a unary function to two different arguments, and then you end up with two results, and so you apply a binary function. So really, atop and over, aka B1 and psi, I really think as like sibling combinators, because they both take a unary function or a monadic function and a dyadic function. And it's just which one do you apply first to two arguments. If you apply the binary one first, you end up with a single result, and therefore you apply the unary operation or the monadic operation. If you do the unary first, you have to apply that twice to each of the separate arguments, and then you end up with two results, which then you feed along to the binary function or dyadic function. And then in between those two, you have beside, which I believe is the D combinator. This is always the hardest one for me to remember, because the psi, or sorry, the D, the delta, and the S and the sigma, it's really just like which argument, either on the left or the right, are you applying things to. So in the monadic case, it's the easiest to remember, because basically you have a binary function and a unary function. You're doing the binary function last, and then you're applying the unary function to only one of the arguments, either the left or the right. In the J language, the to train is the S combinator, which they call the hook, and that's applying the unary function to the right argument, which I think is a shame, because I think the more useful one is what was called the back hook, and I think in other languages has been called the reverse hook. I'm not sure if extended Dyalog APL, which we should talk about at some point, because that's your project. I can't remember if that calls it the reverse hook, or if it's a reverse compose.
Reverse compose, but actually that doesn't have the full functionality of it, because it doesn't have the implied selfie. It doesn't carry over the right argument to the left side when you apply it monadically.
Right.
It's actually the Dyalog, not actually the Dyalog vision, which is my replacement for the extended Dyalog APL. That's where you have the full functionality that I expect to be in the next version of Dyalog coming out, or back hook, or behind, I like to call it as well. So, and I found it really interesting, Connor, that you said that atop and over are the ones that are not just easiest, but also closely related to each other.
Hmm.
That means for you, it makes perfect sense that those are the ones that have the two dots on top, right? And you can, I think of the, when you see the diagrams, I think of the little circle. It kind of matches the little space here uh, between the function that's first applied and the two arguments, and the big circle matches the big space in between uh, the the first functions that are being applied, first function that are being applied to both arguments, and then only later we combine the results.
I have to say, I've never even noticed that both of them share the diaresis, but that is brilliant. And it's also, I've never noticed that if you look at these visual diagrams, one of them has like a bigger tent and a smaller tent formed by the two brace arrow things. That is
Right.
super, super nice, actually. And I
That
think,
is that is entirely intentional, I can tell you, because it's actually switched around from the symbols that Iverson originally used for these. And we switched them because of we thought it fit better like this.
interesting. And yeah, I think, I mean, you can think of too that if you didn't have and the reason that actually that I was doing my master's thesis when I realized this kind of sibling or relatedness between Atop and over, aka B1 and psi, when I was working in Smalltalk, where you can define any operator you want from like a set of ASCII characters, and I was defining these combinators, and then all of your functions that you have in Smalltalk have fixed-arity. They don't have the ambivalence problem of both your functions having both monadic and dyadic. And when you have that, you can basically dispatch on the arity of your function. So you could imagine if you just had the atop glyph or the over glyph, and you knew that you were putting this infix in between two functions, and you knew that you could look at the arity of, or the adicity, if we want to stick with monadic and dyadic. If you looked at the arity or adicity of the left and right function, and you saw, on the left is monadic and on the right is dyadic, you could assign that pattern of monadic over dyadic to be psi, because that kind of visually to me it says like, because the dyadic function is on the right, you're applying that first, because in APL you go right to left. And then if you flip it so that you have the pattern dyadic over monadic, you can define that to be the B1 combinator. And so now you can, in a different sense, you're still overloading your combinator operators to have two definitions, but now it's dispatching. I guess kind of these are already dispatching. It's just contextual based on how many arguments you're passing in, it's just a different model, right? Like you can't do the fixed arity thing.
But it's not, it's still ambiguous in that case, because we've got the other we've got the one that's called beside here as well. So just like with over, where we have a monadic function on the right and a dyadic function on the left, beside also has a monadic function on the right
Right.
and a dyadic on
So
the
you'd
left.
need
So
a
you
different
couldn't
glyph for that one.
you need a different glyph, and the same thing goes for the mirror image of beside, right there. And if you kept the operands the way they are here, then it would be ambiguous with this, of course. If you flip them around so that you have the dyadic function on the right and the monadic on the left, then that's the same thing as the top.
Right.
So you do need, you can't entirely disambiguate based on the arity of
Right.
and which
Yeah.
arguments are being given here. But it's interesting you said that it it fits so nicely with the two dots and the small and the big one, because for me, I always think of over and beside to be more closely related. Why? One is so is preprocessing only the right argument, and one is preprocessing both arguments, and then there's missing one which preprocesses only the left argument.
Right. Right. Yeah. Yeah. I can definitely see that, because it is essentially you are replacing one of the unary operation applications in over, aka psi, with just the identity or attack.
Identity, yeah, yeah.
Yeah.
So which actually you could do with the split compose construct, and that's where that's an alternative definition you could have for three functions bound together, but something you can express if you have the beside and the behind operators. So, um, and that is where you're preprocessing the right argument with one function, preprocessing the left argument with another function, and then any of those or both of them could be identity functions. But then it also bothers me a bit that the beside symbol jot here is symmetric, because it's a very lopsided thing. You're treating the two arguments very differently.
You mean that the glyph is symmetric?
The glyph is symmetric.
Yeah,
It
yeah.
doesn't really indicate which side it goes to. And even if I have it my way and we add the jot underscore and for the other way, there's nothing indicating really which one is to the right and which one is to the left. Um, and they're not entirely equal, but mirrored to each other. So there's a good reason why they're not exactly versions of the same glyph, but one is more complex than the other one, because the behind one, the one that was prepasses the left argument, if you don't give it a left argument, it has a built-in carry over the right argument to the left argument. So that's like an extra
Yeah.
thing. And it's even more interesting because that one was invented by Iverson himself, or invented, I don't know. Iverson listed it himself, and he used an asymmetric symbol for that. He used greater than diasis. And then
For beside initially?
yes, he did.
Interesting.
And he called it with, and which makes sense, right? It's f with the g of y.
Right.
And but with some kind of pun. He loved these kind of small puns. He spelled with a final e, and then the word means.
Is that from one of his like esoteric dictionaries, as Iverson famously would
I,
carry around a dictionary with
we
him?
I guess so. That apparently means to tie something with like a flexible branch. Like there's some like thin branches or it's not leaves, but like the last parts of the branches of some trees that are super flexible and strong, and you can use those as a binding material, and that's what it actually means, which works very nicely, right? Because it is binding them together in this lopsided manner.
Yeah.
And it would be natural then also to have one that points the other way, so less than diasis,
Yep. Yep.
the point to the left. Um, but he didn't do that. He didn't write that one down. It's strange. If I'd been there, I would have said, "Hey, Ken, why? What about the other way?" And
It's so odd because I mean a bunch of people, you, Marshall, myself, like as soon as you start doing tacit programming, even like in the small, it becomes extremely obvious extremely quickly that you want this one. Like probably the most common idiom. Well, is it the most common? Top 5 most common idioms that I end up spelling in BQN is when you want to do a compress with the
yeah,
sigma combinator, aka the back hook, where you're
but-
providing some kind of Boolean mask, which is, taking the odds or, some kind of predicate that's applied to your elements, and you want to just keep the ones that satisfy that predicate. You're building up a Boolean mask and compressing that with the original. And that's, I think, tricky to do in APL because of the ambiguity of the slash. But in BQN, you have, and also, too, you don't have the reverse hook.
oh, you can express it using beside, because you can take the predicate and put it on the right instead, and then you put a commute operator with the slash.
Oh, right. Yes.
And since it's on the left, the leftmost thing, you don't have the issue of it being acting funny. So you can actually do it.
Do we want to show? I mean, I kind of want to go back to the Twitter graphic, but do we want to show that in Dyalog APL for folks? Because
You can show that.
the commute
So
operator is also famously the C combinator.
so so let's say that we have some numbers here,
314,159.
yeah, totally random.
Totally random.
And then we have some predicate function here, which could be, say, 3 is less than, right? And what we would want to write here is with my spelling of it, just like that, right? So we want to apply this predicate on the numbers, and then we want to use that to compress the numbers themselves.
And wait, so just for the audio listener, Adam has somehow magically typed a non-APL glyph that exists in extended Dyalog APL, or maybe you're using the future version that has it built in.
No, you can see in the colors, it's shouting at me that this is not valid.
It's bright red. So it's a jot with an underbar is the glyph
So
for reverse compose or behind.
So we want to write this, but we can't, of course, because that says it's an invalid token.
Yeah.
But what we can do is say, well, if instead of pre-processing the left argument, we'll pre-process the right argument. Then, of course, the arguments are wrong to the slash, to the compress, and we are also missing a left argument because the beside doesn't carry over the argument to the left side. So we'll fix that with two commutes. The first one changes it so that we take the predicate on the right of the compress, or the predicate, the mask on the right. And the second one is all the way to the right of the predicate, where we're going to carry over the argument to the left. Right? So now we filter.
Oh, wow. So it's actually and that's, wow, this is great. So, or do you want to maybe increase the font just one or two sizes? Because this is, I can see it perfectly fine. I'm sure everyone on YouTube can, but this is significant here. So we've got the jot, which is the dyadic definition of this jot, which is the D combinator, which is the one that applies a binary function or dyadic function last, and then pre-processes the right argument with a monadic function. And the pre-processing, because it happens on the right, we want it to happen on the left, which is what the first squiggly double dot diaresis, and that's the commute operator, aka the C combinator. So it just swaps or flips the order that you pass them. But then, because this is the D combinator and it's dyadic definition, it's expecting two arguments. But in this case, we only really want to give it one argument, and that is the argument that will be pre-processed. So we need to then use the same symbol that we use for the C combinator, the commute operator, but in this case, it's actually the W combinator. It's duplicating the single argument to be both arguments. So we've got, the way it reads is compress, C combinator, D combinator, the predicate function P, and then W combinator, which in dialog speak is compress, commute, beside, P, and then what's the monadic? Is it self?
It's still, we still call it commute. Commute is like a common name for both of these two combinators, the monadic dyadic form. But I like to split them up in like swap and self,
right,
or
self.
switch and selfie, right? But it's officially still called commute. Yeah, and I think I noticed how you stopped for a moment there before reading the jot as beside. And I think it sounds like a strange name. And there in the chat actually, somebody is saying that BQN has better named glyphs for the composition operators, and I'm not actually so sure. And there's another comment as well. So you don't really need the jot ever, and because the idea here is that you have a left argument and a right argument, and F and G. And adding that jot here doesn't do anything. It's having F jot G is exactly the same thing as having F beside G. And in the monadic form, having F jot G is exactly the same thing as having just F beside G. Hence it's called beside. Because it acts as if they were beside each other in an explicit expression.
So yeah, in case it's not clear too, what this is relying on is the definitions of the two trains.
No, it doesn't have to be a two train. In an explicit expression. This is an explicit expression.
Okay, no, right. And in fact, actually, reliance on the two trains would make this false.
Yeah, that would make it an Atop. That's different. No, but just in an explicit expression, and then the jot doesn't really do anything. It's as F jot G is just as if F appeared just beside G. That's why it's called beside. And that's justifies also having the simpler symbol. It's the one that basically doesn't do anything. And then I want to add that jot underbar or whatever, if you find a better glyph for it, that I'd like to call behind, because the effect of it will be to take the F and throw it behind the left argument. And if there isn't a left argument, we'll give it a left argument automatically, but it'll always throw it behind like that. And then there's the question of, are they better named? I think they're more consistently named like this, because we use atop and over. Those are positional words, right? Something is on top of something else. Something is over something else, and beside is next to in a special dimension. And I would call this one behind. It's also a special thing. But BQN calls them still a top and over, which is special, and then it calls them before and after, which is temporal. Why would we use
Oh,
time words for one type of compositions, but space words for a different type of
is that
composition?
actually what I was gonna say? Is I thought BQN called the glyph before and after, and then it was just monadic before and dyadic before, and then dyadic before or dyadic after and monadic after. But you're saying that they actually before and after are for the dyadic definitions only?
I think they're always called before and after. It doesn't matter, but it's the
But you mentioned that they also use the names atop.
yeah, but a top and over are the same
Oh,
thing as
right, right, right. But they're
in
different
APL, a top
glyphs. They're
and
different
over.
glyphs.
They're different
So yeah,
glyphs.
yeah,
Yeah.
what I said was correct. Yeah. So actually, yeah. Do you want to bring up the Twitter graphic again? So and
Yes.
the reason I wanted to come back to this at one point is you mentioned that the jot isn't the best symbol for the D combinator in APL, and if you contrast that with BQN's before and after. I mean, you can debate about the names, but definitely the symbols make it way more clear where the kind of
Which way they're pointing.
application, yeah, it's pointing in that direction, which is way closer to the greater than and less than. Was it the greater than equal or less than equal that?
Oh, great. Not equal because that's a normal function, but greater than with two dots on top
Greater than with
is
two
what.
dots.
Yeah.
Yeah, and that one also is quite nice because one, it does look like it's pointing the same way
Yeah.
that the BQN glyphs, but also you could add some extra semantic meaning in that the shape of a less than or greater than, on one side you've got kind of 2 points, and on the other side you have 1 point, which is where the order of the unary and binary functions are being applied. Um,
Yeah. So
Interesting.
it's actually interesting when we were discussing which glyphs to use in what became BQN. Then there were two competing schemes that things distilled down to. One was that which is now used, that one modifiers, monadic operators, use these superscript symbols, and um, two modifiers or dyadic operators use these unbroken circles, is the official rule for rule name. And the other scheme was more inspired by what we have in APL now, but harmonized such that dyadic operators have always two dots on top, and monadic operators always have one dot on top. So, for example, in that scheme, the each operator wouldn't have been two dots, two raised dots. It would have been one raised dot. And its corresponding more advanced dyadic form, the depth operator, would be two dots on top. And the rank operator, if I remember right, was a single dot on top on a minus, so minus with a dot above. Oh, sorry, the cells operator, the one that applies to major cells, would be minus with a single dot on top, and the full rank operator, the more advanced form of the cells operator, would have been a minus with two dots on top. So those pairings between monadic and dyadic forms would be very clear. It's the same symbol, but with one dot and two dots on top. And well, I like that scheme better, but I'm not the one that decided what BQN would look like.
Interesting. So all modifiers, 1 and 2 modifiers, which is what BQN and several other array languages, I guess J as well, although less commonly as the word modifier used in JSpeak, is what these languages call, what Dyalog APL calls operators. Each of them would have the double dot or single dot corresponding to whether it was a 1 or 2 modifier. Interesting.
Right. That would make it very clear, easy to to remember. How many operands does this one take? Well, to count the dots.
Yeah. I did not know that that was an alternative design. It's interesting to think about. Um, so yeah, coming back to one of the things we were talking about at one point is that in APL, you have multiple glyphs for the B combinator, where if you look at the next column, and also I guess C4 Tubo, aka Chris in the chat, asked where this graphic has come from, and I tweeted it out like 10 minutes before we went live, maybe even less than that. And it's actually from a presentation that I've given 3 times at 3 different conferences. One of those talks is online. It's the CraftConf 2024. You can find it if you search for it. I would wait personally for the CPP North version to come out because that's a twice as long, better version of the talk because it's the most recent one that I've given. But what this graphic highlights, obviously, is the different combinators in the form of operators or modifiers across different array languages and Haskell. But also that there are these different composition techniques or strategies, as I call them. And you can see APL, CAP, J, and BQN, they all have certain combinators corresponding to trains, either the 2 train or the 3 train. So you can see explicitly in CAP does not have a 3 train that corresponds to the forks. It uses explicit syntax. And actually, this diagram is technically incomplete because you'll note that where there is a operator, I don't mention that there might also be a 2 train or a 3 train. Well, I guess it's only 2 trains. So technically in APL, the B combinator also can be spelled in the form of a 2 train, but I don't highlight that here, which maybe I should have, but it doesn't really matter.
Well, it just needs another green asterisk over here.
A green
right?
asterisk.
Same thing goes for BQN.
Yeah. And the B1 combinator in both BQN and APL should have a little green asterisk as well.
Right.
So you can highlight a bunch of differences, but one of the neat things is that you can see that CAP actually only has a single. It doesn't do any repeated definitions. So whereas Dyalog APL has 3 different glyphs where the monadic definition is the B combinator, CAP only has a single one, and BQN has 2. And maybe we should chat about this because I think it came up in that we were discussing this a couple episodes ago on ArrayCast, where your argument, Adam, was that a lot of the times having the monadic definition as the B combinator enables you to define intentionally ambivalent tacit functions. Whereas in CAP, and I think even Marshall explicitly said in BQN, sometimes he misses that pairing of always having that monadic definition being the B combinator because there are some times where you want that in order to define these ambivalent functions. Anyways, I'm not sure if you want to elaborate or add that.
Yeah,
how useful is that?
I would say there's a and like an unwritten rule when writing defining APL functions, and that applies both to primitives and to user-defined functions. But of course, the primitives are pretty much locked down. That the left argument, if possible, should be a default. It should take on a default value in the monadic form.
Right.
So this is true for some primitives.
Minus being the best kind of
minus
example.
and division symbol are both
well.
equally good on this, right? Some of them you have to stretch the imagination a bit to make it fit, but you can still do it. And some of them it doesn't fit at all. When the monadic dyadic forms are both meanings are good fits for the symbol, but not for each other. Maybe a good example of that is tally and not match, right? Counting the number of major cells and checking whether 2 things are different from each other there's nothing to do with each other. But both of them are good fits for the symbol because one is it looks like a tally mark, and the other one it's a slash over the equivalent symbol. So and it works well like that. So some of them is not true, but some of them it is true. And it is very often true when people write their own utility functions. So for example, I might write a function that splits a text on some delimiter where the delimiter defaults to space, for example.
Right.
And I might write some conversion format for a conversion function that can convert various ways, but there's like a default way it converts. And so on. That's very common. Some parameters that makes things behave slightly different. Especially, I think, if you look in the defense workspace that we have, there are lots of functions like that. So it's become the norm that you take main arguments as on the right, and then parameters on the left. And when you do that, then it is very useful to be able to write tacit functions defined in terms of these functions you defined before that have an optional left argument, such that you can either give them that argument or not. And that's why you want both the beside and the atop. That in monadic form, especially those two, in monadic form, they do the same thing. And but if you supply a left argument, should that be the parameters to the first function that's being applied, or should it be a parameter to the second function that's being applied? And that's the difference. That's why one is pre-processing and one is post-processing. So um, are you post-processing, but the parameter goes to the main function? That's the top. Or are you pre-processing, and then parameter goes to the second function that's being applied? You just pre-process something with generic pre-processing, and then you have a parameter for the main function that's being applied afterwards. I find that very convenient, and it can be used to a certain extent using the primitives for those primitives where there is something useful like that. And it can certainly be used with user-defined functions and some system functions that are available as well.
Yeah, when you mentioned the system functions, that was probably the thing that made me think the most, because I am on record saying that I very rarely, if ever, in my history of array programming, have defined a tacit function intentionally to be ambivalent. Like they're always defined with ambivalent definition, but I've never designed them that intentionally to use them both ways. But then when you mentioned the system functions, I did think that if you were designing those, probably in quite a few cases, you could come up with sensible defaults for your left argument. Like a great example would be like, I'm not sure if there is a system function for splitting or joining, but those are two great examples where if I think that's even the way that the Python split works. If you just call split on a string, it defaults to splitting on spaces, I believe, but then you can pass it any string you want, and it'll split based on that. I think that's actually like a real-world use case in a different language that is used. It might be the most used function in Python.
You have it in JavaScript with a join function. It will join with commas, but by default, but you can tell it to join with something else.
Yeah, and those
well.
are like the two, like the one of the I started writing some small libraries in BQN, and those were like two of the first functions that I ended up writing, because if you're ever, especially when it comes around to advent of code time, there's so much parsing, and BQN famously, or maybe not famously, but in my world famously, doesn't have the partitioned enclose glyph that APL has, which is extremely convenient in what is one of the probably most frequently used tacit forks in order to split on a character. And spelling it in BQN is very cumbersome. It's definitely something you just want in a function called split with 5 characters. Yeah.
Yeah, I actually brought an example of such a construct you could do with the behind operator, where it would default to the first. Right, I think I remember what it was. Maybe I can even show it. Such an example.
Well, actually, before you switch off of this, because I think we only need this for one more thing, and seeing as you mentioned behind, currently, I think the most recent Dyalog APL is 19.2, I want to say?
9.0.
19.0. And 20.0 sometime, I don't know if it's the year from now, a couple years from now, is going to be getting a behind operator. So does the behind correspond to the behind that exists, or I guess it's be called reverse hook and cap, the jot underbar? Does it map exactly so we can just slide over the jot underdot and we're going to end up with the sigma and delta, or is it going to be slightly different? So what can we expect the monadic and dyadic definitions of the Dyalog APL 20.0 behind operator to get?
Yes, I believe it's exactly the same. So what it does is it's F behind G, means if it's dyadic form, pre-process the left argument with F, then apply G dyadically between the results of that and the right argument. And if you do it monadically, then it will just use the right argument also as the left argument. So that is the same thing as BQN and cap have.
Interesting.
as
So
well.
that is, I mean, that's super exciting because there's 4 combinators, at least according to this table, that Dyalog APL is missing. And potentially, I actually don't think so, but the D2 combinator, you need 2 combinators to
Yeah,
spell
that,
that.
that one will come. That it falls out of having those two, and that just falls out. That it will be there when you have those two.
Does it though? Because you need the S in order to spell. At least I'm thinking about this in the monadic case. So the D2 combinator is where you have 3 functions, 2 unary that you're going to apply to 2 different arguments, x and y, and then you get 2 results back, and you pass those to a binary function. So if you're looking at the graphic, the way that this is spelt in cap is A jot under dot B jot C, where A and C are your unary functions and B is your binary function. And this is very similar to the over combinator, except in the over combinator, the psi combinator, you're applying the same unary function to 2 arguments. In this pattern, you're applying 2 different unary functions. So how can you spell that in Dyalog 20.0?
This jot here.
Yeah.
Well, Dyalog 2.0, 20.0 isn't finished development. It's not in the build I have right now, but I'm very much hoping that will be there. I think there's a very good chance of that. This jot here, that's this one over here, right? And this one over here, that is this one over here, right? Is that right? Am I doing this right? So, but in either way, it will be the same definition of this. So they will just come out the same. We can even do it here. Let's just try it, because the definition of this operator is really simple. So I think I can. Yeah. So yes, you can split. You can split this in the chat here. Somebody's saying you can spell split compose the same way. So let's say we call it B for behind, and the definition is that if you don't have a left argument, we use the right argument for that. Apply the left operand to the left argument, and then dialectically with the right argument, like that. Why is it the colors look a bit funny here? As you can see, it's an experimental version. I'm still working on it. The colors are a bit funky. We've been playing around with some of the coloring. There's a whole lot more happening in version 20 than just this. Then we can try this. We can say we have 10 on the left and 20.3 on the right, and we want to negate on the left, and we want to floor on the right, and then we want to concatenate them together. So we put the B over there, and we put the jot there, and that's exactly what it did. Right, so this is a definition, and we just used it. That's the split compose.
All right, so B here is so I guess let me walk you through why I thought this might not work, and that was because the monadic definition of jot in Dyalog APL does not correspond to the S combinator. It corresponds to the B combinator.
But that doesn't matter because we're using the dyadic definition here. So what happens here binding-wise is that the operators have a long left scope. So we bind like this.
Oh, is that
right?
I've actually misunderstood that about the spelling of the D2 combinator. The 2 operators are using, or like in BQN speak, it's using the dyadic before and the dyadic after in the spelling of D2. It's not the monadic definitions.
Right. So we end up here. This is our main function. We're pre-processing the right argument. That's this one. And then once that's pre-processed, so we can kind of move that over here. That's done. The only thing we're missing here is the main function being in the concatenation. We just need to pre-process the left argument, which is this one. So we throw it over here behind this left argument, remove it from here, and then we just concatenate them together. Okay? So that just works.
Right. So actually, wait, go back to the initial spelling out of it, or it's still out there on the screen. Negative B, comma, jot, min, or floor in this case.
Yeah.
Or it's, to be precise, negate B, where B is the behind operator that we just defined, catenate, which is the comma, jot, which is the D combinator, and then the floor glyph. Walk us through how this gets parsed by the compiler, because this is technically the way that this, if we compare it back to what we had on the cap column, A is negate, our first unary function, and then min is C, our second unary function, and then catenate's our binary function. And then we've got two operators. But it is pretty tricky what's happening here with the forming, so walk us through, because I believe the operators, they go left to right, as opposed to when you're parsing an explicit expression. And because I think if you can understand how the interpreter parses this, you've gotten pretty far into understanding how to read complex compositions of combinators in the form of operators. It doesn't do anything.
So here I'm trying something new. I haven't tried this before, so this may fail spectacularly or crash the interpreter. But again, it's experimental. We'll get there. And somebody suggested in the chat that we could use the token by token tracing. So that's exactly what I'm doing. So that's a cool thing coming in 20 if everything goes to plan, and that is you would be able to trace by through a line of APL, not just line by line. So here, I don't know if you can see that in the video, but it has drawn a thin line around B comma jot floor, which I don't even think is entirely correct. That's what he's looking at here. But we can there's some tools here, and we can open some windows and see what is the interpreter seeing at this point. So we have a function that it's engaging in, and we have a write argument here, and let's see if we can keep tracing here through the. Oh no! Look, I crashed the interpreter. So much for that.
We did start off by saying this could fail.
Yeah, it is very much a work in progress. I will, but it's okay. Let's leave this up because it's going to. If I continue here, we'll close this. So what's happening here is that we have long left scope on the operators. So that means when we go through and parse this, we start here from the right. We start with a value, and we want to know what to do with it. We see there's a function over here. Maybe we need to apply this function monadically. It could be. Or it could be it's dyadic. So we have to look to the left to see if there is another value there that we can use as left argument. So we go there and we see, oh no, that's a dyadic operator. So that means that this function isn't being applied to this argument now. It's being bound by this dyadic operator. Dyadic operator needs a left operand as well. So we keep going to the left and we find a comma there. So that could be revel, it could be concatenate. We have to make sure that it's free to use and isn't being eaten by another operator. So we have to look one step further to the left. We find another dyadic operator, so that's going to eat this comma. So now we know that this jot is going to take something that's B comma as its left operand. But this is a dyadic operand, so it also needs another operand. So we go to the left further and we look, oh, there's another function. And that might also be bound by something. So we go one more step to the left and we see, oh, there's a value. Okay, that means that we're done with our operand expression because this function cannot bind this value on its own. It would need another operator to do that. So we're done. That means this gets bound together, minus B comma. That's a new derived function, which is negate behind concatenate. And then that function is then the left operand of the this composition, which is beside, and now we're ready to apply everything.
So yeah, like in other words too, like it is rather tricky, and I followed exactly what you said, but that's because I've been not for my entire APL life, but 80%, 4 of the 5 years have been studying this stuff. But the way I think about it is I look at this expression. It's very clear that it's like a single composition of things. Minus behind catenate, that corresponds to the delta combinator, which is applying a unary function to the left argument of a binary function applied to two different arguments. And that is going to yield a binary function. And so basically minus B catenate or minus behind catenate forms a binary function. And then that is going to be the left argument to the D combinator, which is the
We call it an operand to
operand.
distinguish it. Yeah.
Yeah, it's good to be precise. And then you've got a dyadic function on the right, a monadic function on the on the left.
No,
a
monadic function on the right. Yeah.
And then that is the flip of what we just did. So where we were applying the negate, the unary function to the left argument, we're going to apply the unary function now, which is floor. I think I just said min, floor, to the right. And then you end up with the D2 combinator, which is applying two different monadic functions to the left and right arguments and then a binary function afterwards, which is, it's beautiful. But up until now, I didn't even realize that these were being invoked in like the dyadic or being composed in the dyadic use cases. I, for some reason, always thought it was like the hook and the back hook. But it's not in this case. It's the, dyadic versions of those, which is...
Right. It wouldn't work as a hook because...
You've only got one argument at the end of the day, yeah.
Yeah. Well, and even the dyadic hook, like Jay will do, that really is just pre-processing one argument.
Well, actually, here's a fun game. Yeah, here's a fun game. So if you get rid of... So let's actually, well, I guess you like you said, you're gonna crash this if you try and close it, but we can verify.
I'll just restart another and take another interpreter. I've got loads of them.
He's restarting it, and while he's restarting it, I will see if I can get this. So let's imagine that we're deleting our left argument. So now we're invoking this expression monadically. We should then end up with, I think, the psi combinator.
So here's a fresh one.
Not the psi combinator. It would be the phi combinator. The monadic fork. So you've got two different unary functions being applied to the same argument with a binary function afterwards. So the monadic invocation of our D2 combinator spelled with behind and beside, aka the D combinator, the delta combinator, and the D combinator, respectively. And so what we should end up with here is just negative 20.3 with 20, correct?
Yeah, we can. Or if you look at the bindings here, this one takes this as its left operand, and we can. That means that we're pre-processing with this. So we start off by making this 20. That's done. Right, so we have this, and then here we have that the same thing as with the filtering. So that means we are negating and concatenating to the original. So we'll get negative 20, 20. If I've done my math right.
Oh, so I was wrong. I was wrong.
But that's because this one doesn't do that thing about carrying over the argument to the other side. Right? That's the difference.
So should we blasphemously bring up BQN pad and and see, or can you confirm that if the jot
we can just define it, right?
Oh yeah. Let's define a what is
so we just say if the jot, whatever, I don't know, what do you want to call it? So if we let's make this slightly bigger. So here it's exactly the opposite. We have the left argument, and then the right argument. Left operand, and then we're pre-processing the right argument. So and that's it.
In case you're a viewer of this that has not stepped into the world of DOPS as opposed to defuns, a defun is just an explicit function that mentions alpha and omega. A DOP, short for operator, mentions either one of or both of the double alpha and double omega, and each of these correspond to the functions. In our case, minus catenate and floor, not all of those three, but that we are going to end up using. So really, you can think of this function that Adam has just defined as a 4-argument function or a 4-argument operator, where it takes 2 function arguments and then after that 2 array arguments.
So now, if we step through this whole thing, predict what it's going to give, then we can't just say this is beside. It's not anymore. This has an implied carry over this argument on the other side, right? So what it wants to say here is we take a function on the left, which because that binds stronger. We take a function on the right, and we're going to take the pristine argument over here on the left. Then we're going to apply that function on the right. So we get 20 on the right, and we got 20.3 on the left. And now it's just a concatenation where we negate the left argument. So we throw that over here behind here, and we end up with negative 20.3 followed by the floor of 20.3. So if I've done everything right, we should get negative 20.3. Negative 20.3, 20. So let's restore everything that we've been doing, so that we can actually test it for real. B, comma. Oh, we already have a comma there, and then we want the J. And yeah, looks like I predicted it correctly what's going to do.
Yeah.
So the monadic form is going to be different than what you have in CAP and in BQN. The dyadic form, which is the only one I've ever wanted, is going to be the same. If you want the BQN form, then all you need to do here is just throw in another commute, another W combinator, right? Then you get that. Because that's the only difference between the CAP and BQN form and the APL one is whether or not it auto commutes or it falls back to monadic application. So it's not like it's a huge extra burden to do that.
This is great. I'm pretty sure we've lost 100% of our audio listeners and potentially 50% or more of the viewers. But this is really fantastic. It's quite. If you're able to grasp what Adam has just shown here, it is really, really elegant.
But in this case here, right, you might say, oh, we're losing out, right, by not having this functionality. But think about it. This is not the right way you should be writing this anyway, because this is just a train.
Right.
This is just a 3 train.
Yes.
There's no.
You would never write it. But the epiphany, if you will, that I had 10 minutes ago when I realized that the D2 spelling is invoking or using the dyadic definitions of delta and D, aka dyadic before and after, or whatever you want to refer to them as. Choose your language, choose your names. And so realizing that uses the dyadic definitions and then asking, okay, well, what does the monadic definitions get you? And then realizing in the case where you have the hook, as it exists in BQN, just gets you the fork. It's a great realization, and it solidifies your understanding of how this is working. But then immediately your next thought is going to be, well, that's fantastic, and I'm never going to use it because that's the 3 train in both Dyalog APL, J, and BQN, and explicitly through the form of symbols. And I guess actually that's a good question.
In CAP as well, right?
Yeah, CAP has.
CAP has you write like this. So that means that in CAP, if I understand everything right, FGH is exactly the same thing as FG jot H. So that thing about not duplicating things in CAP, I don't know. It's the same thing.
Actually, wait, have we? Or no, so okay, this is fantastic, folks. This is. Well, I'm not sure if it's podcast gold. It might be, arguably shouldn't be talked about on a podcast, but it is epiphany discovery gold. Of my mind is exploding just in that little meme. So that's fantastic. The monadic fork in CAP is technically unnecessary. The one on the left here that you're looking at that has the double less than signs and double right than signs. So that is the explicit syntax for spelling both the monadic and dyadic fork. However, the monadic fork is also spellable using, I believe CAP refers to them as hook and reverse hook. I could be wrong about that. It might be compose and reverse compose, but it's the jot and jot under dot. It's only in the dyadic case that these spell 2 different things. In the dyadic case, the one on the left spells the phi 1 combinator, also known as the dyadic fork, and the one on the right that uses the jot and jot underbar, that's the D2 combinator. That is, crazy. It's awesome. What are you? You're saying that this is potentially not a design flaw, but it's a duplication that might have been.
There are slight differences between them, because if you if you have like compound functions spelled out in between, I think these are not actually operators. These are special syntax. They could have been operators,
Oh, so if it's not just
but
single operations, you could end up with a parsing difference.
yeah, there could be, yeah, if there are multiple functions in there, so which ones bind with what because of the
Okay, that
long
is significant.
left goes. Another uh, yeah, it's not just in the middle. It could be any of these. There could be some differences there. That said, you could you can define operators that are just no abiding by normal operator rules that does this thing, that make a fork. That's totally doable. And in that case, it might be nice to have them um, work like this in the monadic and datic way as well, and use them on their standalone like that. But that I'm not sure is doable. Understand what I don't know if that was clear what I said. Right? If we define operators like this so that they are actually that in both the monadic and datic form, it would also be nice if they could then be used separately for those two hooks, right? Or whatever the
Right,
spelling is.
right, right.
And this alludes a little bit to Iverson's symbol, like that, right? You can kind of already see it here. This part of it, that's that one,
Yeah.
right? That's the one you would be spelling it with. So if there was one turned the other way, you could put that over there. I don't think it's doable to define them so that they're normal operator and the operators and they do all the roles. Would kind of be nice. By the way, anecdote quirk: Unicode only has the right facing greater than with two dots. It doesn't have a left facing one because Iverson only used the right facing one, and
Oh
Unicode
no.
just encoded everything Iverson did and didn't try to like think, well, you should also have one pointing the other way because that's a natural thing to do. So
And
that's a bit
if
sad.
you're thinking, what are you talking about? A lot of the Unicode symbols, if you actually go look at the, I think there's some website, and you go look at the names, they're actually named APL iota. They might have an alternative
APL
name.
functional operator iota or something like that.
Yeah, they also have
Yeah.
Greek names, etc. But it's pretty cool. A pretty little cool piece of history is that some of the
Well,
names of these Unicode symbols come straight from Ken Iverson.
they're distinct. They're not synonyms for one symbol. There's an iota that's a Greek letter, and there's the iota that's the APL iota.
Really?
There's a Greek letter capital delta, and there's the APL functional symbol delta,
Those are two different
and so
Unicode
on.
symbols.
Yeah, sure.
Oh wow,
And
I didn't know that.
same thing for alpha and omega. They're also separate. So I think APL is the only programming language that's explicitly mentioned in Unicode. It's kind of cool. So this thing, you could define these operators. I can prove that because if you say I think it's like this. So I'm importing from the defense workspace the FK underbar and the underbar FK. Um, and if we then go up here and get rid of the parenthesis in our fork, I think we write. I think this is the way it goes. There you go. So these are normal operators. You can look at their definition, and they implement forks.
Why do these exist
Uh,
in the defunds? Is this just for fun, or is there actual
it
practical usage for this?
because trains were only or forks were only added to Dialog APL in version 14, which is
Right,
now many years ago, a decade
2014.
ago, and it doesn't go in the year, but yeah, approximately. Um, and these operators precede that.
Wow, look at that, a little piece of
So
history, folks.
you've got this, yeah, the two fork. So it's fork right and fork left, and you got here, and they're not even very complicated, but it's certainly possible. There's actually a difference between them again because of the binding. So you know that um, how you group three functions from the right in a long train, right?
Mm-hmm.
So this becomes a function, and that becomes the right tine to the G
Right.
in a train. However, if there were operators,
Oh,
so
right. It's gonna parse the opposite way.
yeah, exactly. Now we have to bind these two together first,
Right.
and then we have to parse the bind. Uh, I'm missing an O over here. Right. Then we have to bind these two together, and then we have to bind that together like that, and that would make the trains behave slightly differently in
Okay.
that things binding from left, which I think is wouldn't be as ergonomic, but it would be more consistent. And some people say that I've seen that on the APL farm chat room. Some people say there should just be normal operators like that. Don't introduce special syntax like Cap does when you could as well just given it normal operators that abide by the same rules. Then you can just state the definition of the operators, and there's one less thing to learn and remember how it works. So
Interesting. This is a very cool trip down, not memory lane, but history lane. Because I did not know that these existed. The DeFi, maybe in a future episode, I'll have you back. And I know that John Scholes has a bunch of libraries that I think experimented with combinators and spelled them out. And I think he even implemented, I want to say it was two different, I don't know if you want to call them languages, but I want to say that they were called like min and max or something like that.
right, yes,
And I can't even recall what exactly they were for, but they were like languages that heavily used the combinators that he had implemented. Um, yeah.
right. He has a whole like little treatise on Tacit that's in the defense workspace. You can also find it online. We can link to that. Um, where he speaks about Tacit and the rules there, and that thing we did before about using the beside, which was back then only called compose because it was the only compositional operator in Dialog,
Right.
with the commute and the selfie, and he shows that to be I think it shows to be complete for one argument. Like you don't need forks. You
Oh,
don't uh, you don't need hooks. You don't need a top. Over doesn't make sense because there's only one argument. But it can, I mean, it kind of does inside if you've already duplicated the argument. But you can spell everything out like this. So it's functional. Those two together are functionally complete, or three if you want to call them that.
yeah, yeah.
Uh,
Well, so
uh,
maybe I mean we're getting close. We got just under 10 minutes left, and I was thinking that we would end with something different than we have done
okay.
on the other editions, which was talking about our favorite or your favorite specifically trains or tacit expressions. But maybe before we do that, and I'm not sure if you can even speak to this, but if you have any like history of the introduction of the kind of combinators and operators into Dyalog, because as you mentioned, this stuff didn't, there was always a couple of the older glyphs, but the forks, the two trains, and a lot of these operators didn't show up until 10 years ago. And I know that Roger Huey, he came and joined Dyalog, and I'm not sure if John and Roger worked together, but I would be super curious, whatever you know of the history of them working on it and it coming in, and was there a battle? Did some people say, this is not the APL I know, and we shouldn't put this stuff in? Whatever you know, I'd be curious to hear the
Yeah,
any pieces of the story.
I think today maybe Martin Kronberg, the CTO, would be better for that exact thing of the discussion leading up to it. I believe that these two operators in the defense workspace were put there by John Scholes to be able to play around with this idea, this kind of syntax, before it was added to the language. I came to Dialog when version 14.1 was about to be released. It hadn't been released yet. That meant that the latest version was the first one that had forks and tops, and it was very new. It was very foreign to a lot of people. I was mentored, tutored by Dan Baronet, who sadly passed away in a traffic accident a couple of years after that. And he had very much embraced this Tacit thing. He has some old videos back then on YouTube. You can still go and see those on how to read trains and write trains. That was his big thing, and he taught me those things. And uh, he showed that he's the seed for the love of this kind of thing. Maybe much to the chagrin of some of my colleagues that prefer things to be explicit. Um, and it I assume it was controversial. It certainly became controversial later. And we at Dialog we have a very interesting balance to thread, because we're not just language enthusiasts that just want to feel the awesome power of expression when we think about things and or find some special algorithm. We have people who have been using APL for decades. Some of them longer than Dialog has even existed, that have then migrated to Dialog, and they have large code bases that are, of course, and all in old style, or the old code is in old style, and we do run the risk of scaring them away. Right? There's always the possibility of somebody saying, "No, you know what? We're not going to use APL anymore. It's too hard to find APL programmers. It's become an outdated language. There are all kinds of issues with it. Let's rewrite this." And it doesn't have to be the APLers that say that. Right? There can be some new technical management or non-technical management um, that comes in and say, "Wait, what does our tech stack look like?" And then they say, "Oh, APL, what is that?" Or even, "Oh, I had a bad experience with that many decades ago, and let's get rid of that." And adding new language constructs like this does run a risk of alienating people. If we give off the impression that this is the way to do things, and it's hard for the to teach old dogs new tricks, you say, um, that could be that people say, "Okay, enough is enough. We're going to give up on this." On the other hand, we also want to cater to the modern audience. We want to show that we can be with the times, and we can add cool new features to the language that makes it easier to express oneself and not just get things done. Um, so there's definitely some controversy there, and there are still people who question whether it was right to add uh, trains, especially, but maybe also the combinators, or further combinators than what we had. Interestingly enough, the jot was always there, as far as I know, or at least from very early days of Dialog, APL was there. And then the Atop and over jot RSs and circle RSs, they were added while I was at Dialog. They were added in version 18, so it's not very long time ago. And I had some influence on that as well. It wasn't just me, or Marshall as well. He was at Dialog at the time. And he came from a J background, so he was very much into writing things tacitly, of course.
Yeah, I think sometimes I do a bad job of communicating that not always the tacit stuff that I'm showing is. I remember I made a video at one point that was, playing around with tacit, and I took some expression and, iterated on it like 8 different times. And I think I said in the video, I'm not recommending you do it this way, but like it's, like you said, sometimes when you're doing code golfing stuff, it's forcing you to really, really comprehensively understand the combinators and operators that you're wielding in order to do these kinds of tricks. You wouldn't recommend going and programming that way, but like in order to wield them that way, you really need to understand them, which then when you go back to, production code that you're trying to write, just not for the sake of writing it, but also for future people reading it, it really gives you a greater appreciation of how this stuff works. Similar to how I just, realized the actual parsing of the D2 expression. And it's similar to, we had Henry Rich on a couple episodes on Arraycast, and he tries to veer away from talking about the modifier trains and the exotic stuff, as he calls it. And I super want to lean into that stuff, not because I think we should all start going, and writing modifier trains in J or introducing this stuff in all the array languages, but more I think it's just like you're doing spelunking of a very complicated kind of corner, or not even corner. I think like, tacit programming is such an important part of array programming now that in the small, it is like, I can't imagine, it would like rip away half of the joy and love that I have writing in array languages if I didn't have access to these tools, because they become so baked into just like, especially over like the psi combinator. Like just the other day, I was writing some conversion function for like a chess problem, and you needed to convert a string that represented a chess position, and it was like A8 or C4. And you can build up that expression in like, 6 or 7 characters or something. but you then have to apply it to two different positions. And it's like, do I want to write out the convert function twice? It's like, no, you want to spell it once and then use the over combinator. And that's specifically what the over combinator is for. And as soon as you don't have that and I have to type convert twice, it's just like it's like a knife through the heart. It's it's yeah.
Yeah, I mean, I there's a question in chat as well as to whether anybody else uses Tacit Dialog in production, and that definitely happens. I think it's more a question of how Tacit do you go, and so Over has definitely seen some uptake. Right? If you want to do a caseless comparison, we have this the system function in APL now called quad C, which in the monadic form does case folding. Then it's become obvious. You want to do like match over quad C or iota over quad C, so to look up a value and so on. That I think has taken off. Certain smaller things that have become idioms in the sense of not something that's optimized in the interpreter, recognized specially, but just something that you can read in as one block. And I think that there is a benefit in Tacit that it's easier to recognize these like standardized or de facto standardized spellings for doing things like splitting on a character, which we do with different from partition the right argument. Those have definitely seen some uptake, and occasionally you'll have people write other things and slightly more complicated things like that. And so that's I could definitely answer that other people also do that. Connie, you mentioned the Psi combinator, the over, which is maybe the most significant one, and because it allows you to avoid repeating yourself, right? Don't repeat yourself. The other ones are just nice, but don't help you to avoid that kind of thing.
Well, I mean,
And
some of them, like I would even say the W combinator, um, aka self in
that's true.
APL,
Yes, it does allow that
like very
too.
classically when you're trying to build up even the simple things such as like a identity matrix,
Hmm.
you only have to spell an extra two characters plus the parentheses of the iota n for your n by n matrix. But still, that's an additional, two characters that you had to spell initially plus the parentheses for parsing. And with a W combinator, aka self, you can and actually like I think in half of combinators basically is a W combinator. Like even in the technically in the monadic and dyadic forks, having to spell those out explicitly where you're repeating anytime you have to repeat an argument. Like the Psi combinator I think is the
Yeah.
one that stands out the most because it's not the argument that you're saving duplication, which a lot of the times is only going to be a couple symbols. It's the name of a function that you're saving, and especially
Or its definition if it's inline, right? If
exactly,
I only going to use it once, then why should I give it a name there? We could just
yeah.
read it.
And it's
Um,
almost it's
yeah,
almost more painful if you don't store it in a function. Like I can store that chess conversion function in a function called convert. And so it
right.
hurts to spell that twice, but you do that all the time. But if it's a 4 or 5 character expression, which is idiomatic enough that it's not worth naming it, then having
Hmm.
to go and duplicate that twice and you're staring at it and you're reading it twice and you're like, isn't this the same thing? That it's like it's worse than just duplication. You're duplicating the glyphs, but I'd say it's like you're increasing the readability, the difficulty of the readability by like quadratic complexity. Because when you see a single set of symbols and you see it once, like I'd say that like a 20 character APL expression is like it's not a linear progression of the longer the expression, how difficult is it? It's like as you add more characters, the more daunting, exponentially or quadratically does it become to read it. Um,
Yeah, we could take something like this. Let's say I want to see if the two texts have words of the same length in the same positions, right? Which is not the case here because friend is 6 and there is 5. So we could write, and that's a tacit already, right? We can split this one on spaces and split the other one on spaces. And oh, that's not the right thing I was copying here. My copy key not work. There we go. And then we need to count each one as well, and count the other one and each one as well, which we could combine inside this function. So let's do that just for because we're already going a little bit tacit, but we don't still don't have the over operator. Now we need to uh, compare all the values here, and we can see that the first two words have the same length, but the last word doesn't have the same length.
Yeah.
Right? And can expand this a little bit more. But really, this is an over. They're so far away from each other, you might not even immediately notice it. But this is just over that over here, and we can even combine this inside. We can bind it like that, and I think everybody can agree uh, that this is nice.
It's so
And
much better. If you don't agree, you haven't fallen you haven't drank the Kool-Aid yet. You just got to drink it's not even the Kool-Aid because that's like a, reference to a cult, which is not good. This is not a cult.
but
This is so much better.
we got a comment in the chat as to why that table here in the background doesn't have the bird names in it. And I would complain then. It's so clear that the side combinator uh, is useful in this kind of regard. Why doesn't it have a bird name? I have to complain to you.
Oh
This is
yeah, yeah.
Tacit Talk.
We said we were going to talk about this at the beginning, and then we never ended up doing it. So yeah, if you go to combinatorylogic.com, um, which there is a table, I believe that yeah. So if you scroll in
That's
on
this
this,
one.
the bird names are here, um,
Psi is missing.
and it just says psi.
Yeah,
So the question
that's
is
not a bird. I'm sorry.
there a psi bird? I think there is a psi bird.
I have never seen a cybird. I've never heard about a cybird.
Is there a psi bird?
I've never found a cybird online when I searched for it either.
Well, that's a good question.
But the bird name has to ideally begin with, or one of the words has to begin with the same letter
Yeah, that's typically
as the
the idea.
symbol, right? And then so that's why I suggested to you on Twitter that we should call it Citacula, which is a little parrot, because that begins with
Satekla? I think I
yeah.
recall that tweet, and then you slacked me about not responding to the tweet.
Yeah,
Uh,
the bird name begins with PSI, right? So if you were to spell it in Greek, you would spell it with a psi.
Satakadai.
Citacula.
Satakala?
PSITTACULA. I even posted a picture of one.
Satacula.
Mhm.
All right.
You've got it right there.
I'll
Yeah.
edit the I'll edit the site, and then all the other sites that reference this site or use it as inspiration, we'll have to update.
Yeah.
All right.
Okay, established. You heard it first here. It's now the Psi Combinator is
You
now
heard it
officially
first
known
here.
as
It's not the first time we've
Citacula.
named a bird. We've I think the pheasant. Is the pheasant on here?
It's here.
Yeah, the pheasant was named by me before. That one was actually in an academic paper though, so that one's like in the actual academic literature and lore. But Tacit Talk episode 4, that's a close second.
I have to mention to you as well that the Combinator trains from J, as far as I understand, have now been added to TinyAPL. So there is now an APL that has Combinator trains.
Oh, Combinator as in modifier trains.
Yeah.
Interesting.
So basically, all those trains you have in or invisible modifiers, whatever they're called in J, they're now in TinyAPL as well, which makes TinyAPL not tiny at all.
Wow. Well, a spoiler alert. I'm not actually sure if we confirm. I think it's all but confirmed that I think 2 episodes from now in a Raycast we will be having on the creator of TinyAPL. So I think what episode are we on?
This is the. It also has some new names there. The parrot, but I think it's in over here, and I think it even has more, even those that are not defined in. Oh, it goes to the same place. Huh. I don't remember where they were then. This should be here somewhere. And documentation, even more such constructs than the J ones, and if I understand right. So it'll be interesting to see what happens. Maybe it's on the trains. Here we go. Look at this. Look at this. This is you've got enough for the whole week here.
3 trains. Whoa.
Yeah, but you have that in we have that in J as well, right? So here you can see,
So wait, is y an operator?
which I don't know which one you're
So I'm
looking at
looking
here.
at the very first one under 3 trains, and it's
No, so
saying
he's
y uh, tilde diaresis.
yeah. So this is so TinyAPL adds a special syntax for trains. Maybe we need to zoom in more so you can see that those parentheses are not normal parentheses. So anytime you have these white parentheses, hollow parentheses, that means train. Okay, and that because it has a special syntax for trains, that means you can have any syntactic class in any position in a train. So this is a noun noun train, if I understand things right. So array evaluates to the middle array. It is as if, think about it, if this x is a value and you've got values outside the parentheses as well. So this is a derived function and it's a fork, basically. It's a fork where the left tine is a constant function and the right tine is a constant function. And the middle tine is also a constant function. So we apply this constant function to with the argument or arguments that resolves to that value. And then we apply this constant function, and that gives that value. And then we apply this function, which is also a constant function, to the results of these two, and it also ignores its arguments, and then it gives that value. That makes sense? So this is the constant operator.
Oh.
So it's taking what BQN is doing, where it allows for modifiers, for operators, it allows array operands to stand in as constant functions instead of making them functions. They just act as constant functions. Something that we also allow in Dyalog in BQN in the left tine of a train. You can write an array function that just in the left array there it just acts as a constant function. If you add the constant operator, which happens to be the same as the commute, then in APL, then it's the same thing. We also allow it in the at operator, and where you can give the left operand as an array, and it just acts as if it was a constant function. So to here we allow it anywhere in a train, right? So you know this asymmetry that you can have array function,
Yeah.
right? But you can't do function array.
The
Neither in
AGH
APL.
fork, if you've read the
Yeah,
documentation of APL Dyalog
AGH
APL.
right. So if we go back to the APL session here, then we can say we can have a function FGH, right? And we can actually, that one thing I'd like to do is to define a function like this. G and H. So this is a function that just puts its name in front of the argument, so we can see what happened. We can also put parentheses on it, make it a bit fancier, but it will be okay for now. So now we can write FGH, and we need to make the G be dyadic here with an argument. So we can see that this is f of the argument and h of the argument, and then g in between them. Right? Clear?
Yeah, that's a cool little trick that I've never seen before.
Yeah. Then we now can make an array that has the value a. So we can do that here. So then we get the AGH train.
Yeah.
But we don't allow the a over here because this becomes an explicit expression. But you can still do it. You just add the constant operator to it. Now this is a function, and everything is fine. Right?
Wow, that is
So if we do h over here, and we do array in the middle, then we're still going to apply F and H, but the A is just going to eat up everything. So the side effects of these functions, if there are any, will happen, but we don't do anything with it. Now, if we create also B, which is just an array, and C, which is just an array, then we could use constant functions everywhere, right? So this is just a normal fork. This resolves to the value of C. This resolves to the value of A, and B is going to entirely ignore that. So if we allowed completely substituting arrays for functions in any position in a train, then naturally the array train should resolve to the middle array. Yeah?
Yep. Yeah, it makes
Uh,
sense. So really,
That's
the first
why,
these four first of all, like the main thing I missed is that why constant, aka what is also the self and swap. That's all. I always forget. I don't think I've actually ever used constant as a combinator, which you just showed me an extremely useful use case. Anytime I've ever wanted an array as the right time, which isn't possible, I've always
right,
ended up just commuting the middle tines so that you can stick the array. You can have an AGH fork where the tilde, or not tilde diaresis, aka commute, is applied to the binary function, and that is effectively the same thing as being able to spell
but
FGA fork.
it reads much better. So here's the average of these two values, right? It's the sum divided by 2. But it would be much nicer to spell it as the sum divided by 2,
And
which
then
you can't.
you
But
just
you just
remove
add
it.
the constant, and then it reads
Oh
much nicer.
man.
And it's the
Oh
same
man.
length.
So many epiphany moment. Or not. This isn't an
But
epiphany. I just learned something, but still, it's so
but in
awesome.
TinyAPL, we allow it everywhere. So we can, I don't know if this will work font wise. It will look funny. Maybe if I change the font, it will. Yeah, there we go. Here we allow anything in any position. We most certainly can write plus divided by 2. And we don't need that to make this array into a function because we can have arrays in any position of a train.
Do you? I mean, you're not the person to ask because you didn't create TinyAPL. But why do you need the diamonds?
That it's special syntax for trains. It wouldn't work to write without diamonds
Why not?
because because this would evaluate. How are we going to parse this?
I mean,
How are you going to say what belongs with what in the tines? Or how we do, for example, if we wanted a third inside a tine, you can't write a third, you can't spell it out because it has infinite number of digits after it in principle, right? So you want to write it like this. So, and let's say you want an array over here as well. For whatever reason, you're doing this kind of things. How are you going to decide what belongs with what? Parenthesizing is not going to help, right? That still makes them. So this is a special syntax that you use the diamond, apparently. I mean, it's a brand new thing. I haven't played with it. So now you
then
can write it like that.
why wouldn't parentheses work? No.
Well, that makes them for adjacent to each other. So let's say the middle one is a minus, right? How are you to say if this is the negation of the reciprocal of 3, or if the serve separate purpose? Is this a fortran, or are we dealing with a third here? So we had to parenthesize this, you're saying?
Yeah.
But what if I want to negate it? And it seems a bit scary, the whole thing. I guess that's why it is. Maybe it's just for parsing purposes. Maybe it would be possible to come up with a scheme where it all works. I guess it's possible because essentially that is what the I language does. So maybe with these parentheses would be enough. It would be right? In the I language is taking forks to their logical conclusion. Everything is a fork. You can't even have, if as far as I understand, an even number of things on a statement in I. They must be odd. Everything is a fork. And even if you want to apply something supposedly monadically, you can't really do that. Then you have to use the apply function with an argument on the right and a function on the left, and then the middle of the fork is going to be the apply function. So maybe it's possible. Maybe it's just a parsing thing, and these parentheses are enough to indicate what's what. especially because TinyAPL doesn't have implicit stranding. There's no invisible stranding between adjacent things, and just like there isn't in BQN. So maybe it's fine. Could be.
Well, subscribe to this channel
But
and also your Arraycast in whatever podcast listener, because we'll be talking to the creator of TinyAPL, hopefully in T-3 weeks or something like that. So you'll be listening to it in T-4 weeks. And it seems like if, I believe Madeline is her name, if she's willing, she'd be a fantastic guest to talk about all this stuff on a future Tacit Talk episode.
here you have an example with the sum divided by 2. It's stated funny here, but it comes out the same, right? This is just binding the right argument over here and applying it to the result of f. Is that right? Maybe not. Maybe it does something else. No, that should be that's the same, yeah. Because it's on the top with a function that has the right argument. So the result of this becomes the left argument. So that's just f g z. That's it does. Yeah. You got it. Yeah, those would be interesting to hear. It would be interesting to hear the reasoning if it's just for ease of parsing, or what it is. I'm not going to suggest we do this in Dyalog APL, for the record.
Yeah, I'll have to spend some more time looking at this. This does look rather mind-blowing. I think also NARS 2000 has a similar combinator table to this kind of stuff where
But it doesn't have
the new syntax and all this.
It doesn't have trains of combinations. You can't even give each a name, which is something you could do in J even when they didn't have the combinator trains.
Each you can.
Yeah,
I thought NARS 2000 did have hyperrators.
it does have hyperrators, but each is not. There's no hyperrator there. You could define a hyperrator that takes 2 monadic operators and derives a new monadic operator. Sure, you could, but then you'd have to have then it would be an invisible hyperrator, right? So there's definitely a lot there.
Okay, we said half an hour ago that we were going to finish with favorite tacit expressions, but maybe we'll only let you choose one, Adam, because I do got to let you go. You've got a family of kids to attend to. If you had to choose one tacit expression, can be a train, can be using an explicit operator.
I mean, it depends what the purpose is. I don't have
elegance and beauty. That's what I'm looking for. But you can use your own forcing functions.
Not a cool party trick, you're saying?
I mean, a cool party trick could be beautiful.
I'll show you. I'll let you judge you what you think about it. So do we still have? Oh, we don't have these numbers anymore. So we've got our random numbers here, and we can write. This is fairly well known. We can write the average like this, right? But sometimes you want a running average, right? And part of it works if you have a left argument to the sum. So here's an example. It's not a primitive, but it's a derived function from primitives where the monadic and dyadic forms works very well. We've got a reduction, and then we've got a windowed reduction if you give it a left argument. And it's as if the default left argument was infinity. It's not quite, because there's something with the rank, but it's pretty much. It's easy to understand how they belong together. The problem is that this function doesn't work. I mentioned that before. The tally when it's monadic and it's not match when it's dyadic. And those don't work together. So we want to fix it up. We want to have a function over here that makes sense. And if we're doing windowed reduction, and we want to get the average, then the value we want to divide by is the length of that window.
Yeah.
And we have that. That's the left argument. So I want the function that gives me the left argument when it's dyadic, and the tally of the right argument when it's monadic. Right? That doesn't exist. However, here we take that left identity, if it exists, and pre-process the right argument with tally. Okay, so what happens if we use this one dyadically. Remember, this is when we're using the JOT, it's preprocessed right. So that means this is the main function. Main function is to choose the left value if it exists. But the monadic form of the left function is to choose the right argument because there's only one argument. So if we're calling this dyadically, then we start by counting the right argument, and we throw that away because we just choose the left, that's the 3. And if we call it monadically, then we are still preprocessing the right argument. So the main function is an identity function, doesn't do anything. And we're preprocessing by counting, which would give us 5 over here. So this is a function that in the monadic form is tally, and the dyadic form returns the left argument. Therefore, this is the running average. And you remove the left argument, then that's just the average.
Is this the expression that I've seen on a T-shirt?
I think you've seen a similar one, but that one is monadic. That's the one that indicate which numbers are greater than the average. I think you've seen that.
Right.
So it's this one.
Right.
That means greater than average. Or I like my extension of it. What's the population of greater than average? Right? So we can do it like that. There are 3 numbers in this collection that are greater than the average, which you can see. We found out the average was 2.8, and so that 3, 4, and 5 are above average here. But this one's the one that you can buy. I think it's Aaron Su that has his store.
Yeah.
That says that one.
It does look like 90-80% the same, which is why I was.
Yeah, and we can actually do this even better. I'll up this one more step, and there is another problem with the normal average. And that is if you try to do an average on an empty array, then you could say that's meaningless. It doesn't really make any sense to do an average. But by convention, APL has like harmonized mathematics, and I think there might have been a wrong decision made to say that because all other numbers, when you divide them by themselves, should give 1, and 0 divided by 0 is not defined, let's make 0 divided by 0 also 1. So that we can blanket say all numbers divided by themselves give 1. But that means that the sum of an empty vector, that's clearly 0, identity element of summation. And the tally of an empty vector, that's also 0. So 0 divided by 0, that gives 1 according to that principle. And therefore, the average of an empty vector is 1. And most people kind of don't like that, because where did the value come from? There's nothing. If we start off the origin point of 0, there's nothing that would pull us in the positive direction from 0 when there are no numbers there. If anything, it would make more sense if the average of an empty list would be 0. And that's because of that thing about 0 divided by 0 gives 1. In J, 0 divided by 0 gives 0, and that might have been a better decision. And we can tell APL actually to do that. There's a system function called quad_div, or system variable called quad_div. If you set that to be 1, then this works out. But because it makes 0 divided by 0 give 0. But the default is that it doesn't do that. But I can fix that, because when we have the average, then I can take the maximum of the tally and 1. That means we never get 0. We'll always get 1 or more, which means we get the sum, which is 0, divided by 1, which is 0. So now it works. And if we combine these two, then of course we can't do. It doesn't make sense even to do windowed reduction over windows of size 0. But if we did, then we would get 0 as well, and we beat 0 by 0 by 0. That would also give us 1. So that doesn't make sense. So that also fixes it. So we'll always divide by 1 instead of 0, and this allows us to have our ultimate average function, and that allows us to do windowed reductions and normal reductions over both arrays that have content and arrays that they can't do that. Arrays that don't have content, and they always get a reasonable answer. So this utilizes a lot of that tacitness that we have. We've got an AGH train here, and we've got a dyadic function composition where we're using JOT to its fullest extent, the way you can't do it in BQN. And we've got plus reduction is also a tacit thing, and we've got a normal FGH fork over here, and it's ambivalent. The whole thing can be used both monadically and dialectically. So I don't know if it's my favorite, but I think this is pretty cool.
I think, yeah, even if it isn't your favorite, it is a fantastic tacit expression to highlight because this is an example of one of the ambivalent tacit definitions that I have said that, I've never written, but here's an example of one where you're building something up, which is a pretty reasonable, right? Like the default of just taking the average, but if you want to do running average, like those are two things that are definitely super related and make sense, right? So I think pretty good example. I think with that, I'm not sure if this just broke the record. I think it might have by 5 minutes or so, the longest Tacit Talk episode. But yeah, thank you so much for coming on, Adam. I think we're going to be chatting again in T- after the weekend for a Raycast episode 85 or something like that. But hopefully we'll be able to get you back on a Tacit Talk episode. I've mentioned that the ultimate goal is to collect a bunch of language implementers and have you guys have a panel where I get to kick back and just watch you guys debate, one array language to rule them all, even though, as Elias mentioned, there's quite a lot of respect between language implementers, whether it's different APLs or languages like WeWaJ, BQN. And yeah, this has been a fantastic chat. I've learned a ton of extra stuff. My mind's going to be buzzing about the D2 Combinator and also the constant function that you can use to get a FGA fork. Didn't realize that was possible. And yeah, until next time we chat, thanks for coming on.
Thank you. I suppose the customary greeting at the end will just be left unsaid, right?
Yeah. I think you're not the first person to make that joke. That yeah, we don't have a sign off here. And I guess we should, as a final exit, just say we mentioned at the top. But if you want to go test out, I think this is the actual Dyalog APL IDE, or is it Ride? I can't tell.
What is the Windows IDE that doesn't exist on other
IDE.
platforms.
But we'll leave links. You can go and play around for free. Dyalog.com. There's the Windows IDE, but there's also an open source Ride editor, which is my IDE of choice when I'm messing around with Dyalog APL. Someone mentioned in the chat you've got the Dracula theme, which I think at one point I just casually mentioned on some talk that I gave, and then like 2 days later, Adam had implemented it, and so it's all there. So yeah, be sure to check out Dyalog.com. And yeah, once again, thanks for coming on, Adam.
Sure.